Hi everyone, welcome to our session. My name is Basak, and together with my colleague Maria, today we will tell you a story, how we changed the mindset in our organization to implement MLOps practices. So probably you are familiar with MLOps. It is a set of practices to put machine learning models into production and maintain them. And it has become quite popular recently. This plot is taken from, are you seeing this? Yes. This plot is taken from Google Trends. It shows you the popularity score of MLOps search query. And it is not a coincidence that we see a drastic increase. What else is not coincidence is that there are a lot of talks and tutorials around MLOps. I guess we also represent one of them. But mainly they are focusing on the certain key concept of MLOps, such as model registry, such as monitoring, tracking, or they explain you how to use a certain toolkit, AWS SageMaker, Azure ML. But we found only a few talks around MLOps adoption challenges, because it is actually very difficult to apply MLOps and bring your existing infrastructure to the MLOps level. So we talk about challenges, and we would like to highlight two main challenges that comes with MLOps adoption. Fragmented MLOps toolkits. There are so many product software that solves different problems. You see all these products also here. They are great tools, great softwares, but you always have to find a creative and smart way to combine them to build your end-to-end solution. Or if you choose to use a product that provides you end-to-end solution, then you have to find a way to integrate that software into your existing infrastructure. Usually that takes quite a lot of time. The second challenge that we observe is organizational change. You might need to hire machine learning engineers. You might need to train your data scientists. You might need to explain what MLOps is to your platform engineers, because often they are not familiar with this term. So this takes also a lot of time. So we have faced all these challenges and we survived. So we will tell you our recipe, our secret. What worked for us might also work for you. But before we jump into that, let's have a look at what type of organization we are working at, and you can see whether it is relatable. This is Ahold Delhaize. It is a retail chain, food chain, and it has 19 brands across the globe. And we are working at Global Support Office. It is a central unit that supports different brands from different angles, and data science is one of them. So we have a chance to look at all data science teams from a central perspective. When we started working at Ahold Delhaize, we had two ambitions. Increase reusability of code between brands, because we have many brands, they have e-commerce website, they all want better search engine, they all want personalized offers, they all want demand forecast to predict the sales. So why not reusing existing ML models across the brands instead of reinventing the wheel? But this is only possible if you have already mature MLOps system. So this brings us to the second ambition. We had to boost MLOps in our organization. So I already mentioned that we had many brands, and some brands have really advanced data science team, and some brands don't even have data science capability. In order to see the difference between those brands and also quantify the gap between them, we conducted a maturity assessment to see their maturity level. So you might also have seen this before. This is maturity levels starting from level 0 to level 5. This is not something we invented. This is something we got inspired from Microsoft, Google. They define these maturity levels and they also detail them very clearly. But they usually look at the organization as a whole. What we did, we looked at each model, each data science project, and each brand separately. because we wanted to identify the brands that are between level 1 and level 2. Because we had this motivation. If we bring all our brands, all our data science teams into level 3, where we have at least automated ML deployment, then we can actually start reusing projects between brands, the code between brands. So we identified those brands, and we decided to focus on those in order to start our MLOps transformation. Before I actually go to the next, I would like to give you a concrete example for you to understand how we actually assess those levels. This is a cross-sell model. It's a model that runs on our e-commerce website. It suggests customers irrelevant products based on their choices, based on the products they put in their basket. So it always starts with a notebook, a model in a notebook. Our data scientists love to start with notebooks. So this is level 0, where we have a model running on a notebook. And at level 1, we have DevOps, but not MLOps. So we have DevOps engineers or DevOps team who takes the model artifact from data scientists and then puts them into production. You can think of data scientists producing model artifacts, pickle files, zip files, and sending them to DevOps teams via email, via shared accounts. So this is level 1. At level 2, we have some sort of automated training, but training is still disattached from the deployment. So again, data scientists are responsible for training, and they send the model artifact to DevOps, and DevOps team run the deployment pipeline. This is level 2. As you can see, at level 3, we have both automated training and deployment pipelines, and they are attached to each other. So there can be one pipeline, or there can be 2 pipelines that triggers each other. At level 4, we have more advanced components, such as monitoring, such as feature store. Our model cross-sell got stuck at level 2. So we wanted to understand why this is the case, why we cannot go up until level 3, level 4. Well, we found out the reason, which was the way of working. So the way of working didn't allow our machine learning models to come to the level 4, level 5. And the way of working was the following. We had isolated data science team working in development environments and running models, doing data explorations, but they were not allowed to put any model in production. It was still the responsibility of platform teams. So platform teams were responsible for the infrastructure, for the data delivery, and they were also doing deployment to production of those machine learning models without even understanding what is happening there. If any kind of issues, any kind of bugs, it will take so much time to actually understand and fix for data scientists. The way of working we call throwing over the fence, because there is a wall of confusion between data scientists and DevOps engineers. So far, I only talked about problems, errors, what went wrong. So for the fun part, I'm passing to my colleague, Maria.
Hello. So how can we actually break the wall of confusion and move further up a MLOps maturity ladder? So we decided to start with the MLOps standards. So when DevOps engineers brought models to production, they actually had some kind of checklist what they need to do. But these standards didn't account for the MLOps principles. So we decided to start with the checklist for them when they put models in production, what do they need to think about. And there are 4 main parts of it: documentation, code quality, traceability, and monitoring. There are more things you could think of, things like feature stores. We have them in the assessment that we do for the brands, but they are not part of the standards because we are not mature enough to go there. So starting with the standards, we have documentation. For example, you need to document KPIs and the business goals, have some software architecture design, and the machine learning model choice needs to be justified. So why do you choose a more complex neural network model comparing to logistic regression if it's harder to put in production? That's one of the examples. Code quality. code review needs to be done for each pull request. There should be automated unit and integration tests run before models are deployed to production. And release notes should be created at each release. For traceability, for each deployment, we need to be able to see what code was responsible for this deployment, what infrastructure in the environment was used to train the model, and also what model artifacts were used to create those predictions. And for monitoring, we need to monitor API requests and responses. We need to do offline evaluation of our models, and also we need to monitor the KPIs to report back to the business team. The DevOps engineers were not happy with the standards, didn't understand why we need to have those in place when they were just doing fine according to them. So we decided to come up with the methodology of the data science project and explain why behind these standards. So documentation, for example, is needed because of reusability. We want to be able to reproduce the results. And also, if someone leaves the company, we need to be able to maintain the solution. Code quality is important because mistakes can happen if people don't look at each other's code, but also errors can occur in production if we have not done the proper unit and integration testing. We need to be able to look back why model had certain prediction, because sometimes weird things happen. Like we had a moment that our personalized offers model was giving suggestion of very expensive gin to our customers, to all of our customers. It wasn't justified at all because, well, gin is probably not the most popular item anyway that our customers buy. But we were not able to find out why the gin was given as a suggestion to our customer because the model that was in production wasn't traceable at all. So now we can see the code and the artifacts and everything related to the prediction and analyze why model is behaving in a certain way. And monitoring is also important. Our model was producing a wrong prediction for a week and even was down for some time. And no one knew because there was no monitoring in place. So monitoring is crucial. So after we came up with the methodology, the why behind the standards, we finally were able to convince the DevOps engineers in our platform team to work together with us. And the thing that we wanted the most for data science teams to be responsible for their own deployments. Before, the deployment was in hands of the DevOps engineers that had no idea about the code, but now the data science team has access to service users to be able to deploy things in production themselves and follow the MLOps principles by design. And the platform team supports the MLOps standards. So that's a huge difference in the way of working that happened. It took us a year to convince them to change the way of working, but we achieved that because of the standards and methodology. So the recipe for our MLOps transformation consists basically out of 3 parts. The data science project methodology, explaining why we need to follow MLOps principles, MLOps standards, it's a checklist before you go to production, and maturity assessments to find the gap. So for each project, we go through the standards and assess what is missing and where we need the improvement. But is there something missing? There is a 4th component we haven't mentioned before, the golden path, telling how to follow the standards. Golden path is a term, you may have heard of paved road. Golden path is something that Spotify have come up with. It's the solution that is easy to follow, that allows you to follow the principle by design. You can go and invent your own wheel if you want, but it's much easier for you just to follow the golden path and ensure that you are following the standards. So the golden path, examples of those, for documentation, we come up with the guidelines and templates for project documentation. We have guidelines of how to do automated documentation of your code. For code quality, we have some cookie cutter templates and we use for all our projects, and guidelines on best practices. For example, how to do branch protection rules and how to ensure that code is reviewed by multiple people and integration tests have run properly. For traceability, we have reusable CI/CD pipelines that do traceability by design. And we also have internal Python packages that help with traceability. And monitoring, we have internal packages that talk to the monitoring tools, and we are working on centralized monitoring solution that be used by multiple brands. So example of the golden path of traceability is a solution that allows to see what code and what model artifact and what run was responsible for producing a particular output. So if we're looking at the cross-sell model that was mentioned earlier, it's an API. So when API is being called, we want to see in the response body what git commit hash and what run ID was responsible for that. So when we train our model, we use two things. We use GitHub Actions for CI/CD, and we have Databricks for compute. So in GitHub, we can get git commit hash and pass it to our jobs that run on Databricks. In Databricks, we can retrieve the run ID of a particular run, and these two things is a unique identifier of any run that you have. So these things are being passed to the model registry. We use MLflow for this purpose. And when we register our models in MLflow, we tag our models with a git commit hash and with the run ID. And then we create a Docker image. Model is baked into the Docker image. We have it for multiple reasons, because it's not always easy to connect from the Kubernetes service to another subscription containing the artifact. We decided to keep it all inside the image. And in our image, we also tag it with the information containing git commit hash and the run ID. And this is also becoming environment variable inside our Docker containers. And because it's available, we can also pass it as a response in our APIs. That makes it easy to do rollback and also to do A/B testing. If we want to run multiple versions of the model at the same time, we need to know what model was responsible for producing this result to analyze it later. And that's a solution that we have created, and we haven't seen that much at other companies. So the key takeaways from our talk. You need to start with understanding your organization and where you stand from an MLOps point of view. Then you need to motivate why MLOps standards are needed and involve the key stakeholders in this process so that they support you in your MLOps transformation. Then you need to make the standards fit the current MLOps maturity level. So as we mentioned, we only started with the 4 main parts of the MLOps standards, while model explainability, ethical AI, feature store, and all kinds of things, we have thought about those, but we cannot make it standards yet because we are not there yet. And of course, we need to train the data scientists because that's where your ML starts. Your ML starts with the data scientist, and if they just start with creating notebooks and having 1,000-line code there, it will not help you in bringing these things to production. So we need to train them to use version control properly, write unit tests, creating Python packages, and support them in this journey. Thank you for your attention, and we will be happy to hear your questions.